Hi, this video is to talk about the inference about proportions of two populations. This is chapter 10, and what we're doing is we don't know if two population proportions differ, and we're going to build a confidence interval for the difference between the two population proportions. And remember, we don't have access to the entire population, so we're going to use a sample data, and we're going to establish some confidence levels and find the z-scores related to this confidence level to come up with the interval estimation for these differences. Okay, so let's have an understanding. This understanding goes through the sampling distribution for two populations. The sampling distribution for two populations have two values, two called parameters. One is the expected value, how much we expect these proportions to be different in the population. So the expectation is that when we use a sample to represent each one of these populations, we expect that the difference between these sample proportions be equal to the difference in the population proportions. So we are like making the assumption that the sample resembles what happens in the population. However, because we're using sample data, we have a standard deviation. We have a standard error for these differences. These differences will be different for different samples. Imagine we collect different samples. I collect one sample, you collect another sample, and each one of us collect different samples. Each one of us is going to find different differences, and that's going to give us a variability, which is the standard deviation of the sample proportion for these differences. Okay, this is what this sigma letter is representing. The sigma has the difference between the sample proportions and is given by this formula. Okay, and this is the proportion in sample 1 and sample size in sample 1, proportion sample 2, sample size in sample 2. Okay, so we're going to be using this to come up with our interval estimation. We are going to also have two conditions. Okay, remember those conditions from previous chapters. Okay, so we have a more like detailed explanation about this in chapters 8 and 9. So I'm gonna go to an example so you can understand. For example, a tax preparation firm is interested in comparing the quality of work at two of its regional offices. They select samples of tax returns prepared at each office and verify the sample returns accuracy. Then the firm will be able to estimate the proportion of erroneous returns prepared at each office. So we have a tax preparation firm. They prepare tax return forms, and some of them have mistakes. So let's take a look at the data. So in Office 1, we have a sample size of 250 tax returns filled out, and the number of tax returns with errors is 35. And in the office number 2, we have also 250, and we have less errors, 27 tax returns with errors. So if we divide 35 by 250, I have the proportion of tax returns that are erroneous. Okay, so this is what we have here: proportion of erroneous returns for population 1, proportion of returns for population 2, and then the sample proportion. So 35 over 250 minus 27 over 300 gives us 0.14 minus 0.09, which the difference is 0.05. This is the expected difference. Okay, so this is the number that is going to come in this formula. Okay, which is our differences plus and minus a z-score divided by the standard error. Okay, so this is how the formula is. And remember, this is a z-score which is based on the confidence level. So if the firm wants 90% confidence, the z-score associated with this 90% confidence is 1.645. And if I multiply by the standard deviation, which is this formula here. If I multiply by this formula, then I get the margin of error. So this number, the z-score associated with the confidence level multiplied by the standard deviation of this sample proportion differences is going to be our margin of error, okay? And we explained this in more detail in previous videos too. So if I get this margin of error, if I do this math multiplied by the z-score, I get 0.045, and if I add and subtract to the difference in the sample proportions, which is these two numbers, if I add and subtract, I have the lower and upper limits of the confidence interval. So the answer would be something like 90% confidence interval for the difference in the proportion of erroneous tax returns prepared by the two offices is 0.005 to 0.095, okay? Which is the result of 0.05 minus 0.045 is this number. 0.05 plus 0.045 is this number, okay? In the next video, I'm going to show you how to do that in Excel. That's it.